So on Tuesday, if you recall, and what we talked about a little bit in class yesterday as well, was our ability to now solve these exponential equations. All right, so we'll be on the back there. So first section, we talked about the graphs of an exponential equation or exponential function. We talked about some different characteristics that they might have. Tuesday, we talked about how to solve these equations. And yesterday, we just did a little bit more practice with that. And the thing, or kind of the objective and our idea behind how to solve these, is to try and make sure that I can get it to an easy equation that I am comfortable with, right? A linear equation where I just have those 1 and 2 step moves to try and get the variable by itself. And our steps for doing that, if we can recall, is to rewrite each side so I have that common base, right? Because if we can have a common base, what we can eventually do then is use our exponent rules, like you see in step 2, to help simplify our exponents and then set them equal to each other. And that's our way to get to an equation that's easier for us to work with, okay? The same steps are going to apply to what we're doing today, except instead of dealing with an equation, we're going to be dealing with an inequality. All right, so think about some of the different aspects of what an inequality is and what it means, right? Instead of getting one solution like we might have for an equation, now we're getting a range of solutions. So my variable x is greater than this number. So that range of possible answers is going to satisfy that inequality, all right? Our inequality symbols, remember, obviously are greater than, less than, greater than or equal to, less than or equal to. And there's only one real rule relating to inequalities that we have to keep in mind, all right? Who remembers there's just one rule that's going to flip my inequality symbol when I do a certain thing? When you divide by a negative, good. So when we're going through these problems, whether it's in these first couple problems right here, whether it's on the check or in your homework tonight, the only real difference between what we're doing in equations and what we're doing now is just we have to take into account that rule, all right? And obviously, which we already discussed, the range of values rather than just one solution, okay? The steps are going to be similar, though. All right, so I'll go through example 1 kind of on my own, give us a chance to refresh our memory with this process, and then we'll go through the rest of them kind of together, and then we'll move on from there. So number 1, I have 5 raised to the 5x minus 2 greater than 125, right? And when we see these problems, a lot of times what we think to do is just keep whatever that exponential function that they give us the same, right? So I'm going to leave the left-hand side as is. And my first goal is still the same as it was with equations. I'm trying to get a common base. So if 5 is my base on the left-hand side, I want my base to be 5 on the right-hand side. Then I have to ask myself, well, if I'm changing 125 so as a base of 5, what do I have to raise 5 to get to 125? So what should my exponent be? So the third power, good. Right? Do you need to use any resource that's going to help you understand what that variable should, or what that, exponent should be? If I have common bases and I don't have any exponent rules to worry about because my exponents are as simplified as they can be, now what I can do is just set those exponents equal to each other. But now instead of being separated with an equation sign or equal sign, they're going to be separated with equality. So 5x minus 2 is going to be greater than. Everybody with me so far? Are there any questions? Now that I have this, I have an easy 2-step equation. I'll add 2 to both sides. I get 5x is greater than 5. Divide by 5 on both sides. So I know that x has to be greater than 1. In order for this inequality to make sense, right? So any value greater than 1 is going to satisfy this inequality. And it's important for us to understand that, anticipate what inequality you're dealing with. So like a number 1 greater than, number 2 less than. That value cannot be equal to 1. All right. So when you're plugging in values, maybe to check your answers, you can pick anything so long as it's greater than that value. All right. And it should satisfy the inequality. If it does not, probably means that you made a mistake somewhere, either with your inequality symbol, maybe you forgot to change it if you divide by a negative, or you plugged in an incorrect value, you made a mistake somewhere along the way. So make sure that you go through and actually check. For example, if I plug in 2, well, 5 times 2 is 10, 10 minus 2 is 8, 5 to the 8th power is obviously going to be greater than 5 to the 3rd power, right? And what I would suggest doing, I know I'm kind of harping on this point, but I would suggest plugging it into the formula that you have the same base. Okay. The reason for that is, or you can just kind of compare the exponents rather than comparing the values that you get. All right. Is everybody clear with that? Does that make sense? Any questions about the first example? Okay. Example 2. So I have 1/4 raised to the negative x plus 4 is less than 2 to the negative x plus 16. If I'm looking at this problem, which base should I keep the same? So what side should I not change, essentially? The 2, right? So I'm going to leave, bless you, the right-hand side as 2 to the negative x plus 16. All right. But if my goal is to get the same base on the left-hand side, then it should also be 2. Now I have to think to myself, well, if it's a fraction, we talked about this on Tuesday, the light bulb should go off in our head. It's going to be 2 raised to what kind of number? Is it going to be a positive number if I have a fraction, or a negative number? Negative, right? Because I know that negative exponent is going to give me the reciprocal of something, so that's what creates my fraction. All right, and you're going to see examples like that not only later on today, but also in your homework. So just be aware of that idea. All right, so you'll eventually distribute a negative right through. Very similar to what we saw before. It's just now, instead of having a positive number, it's just negative. Well, 2 raised to what power? Because our next focus should be, well, how do I get that how do I get that number in the denominator there? 2 raised to what power gives me 4? Negative 2, right? That's what's going to give me the 1/4. So I know it's negative because it's a fraction. I look at the denominator, I know it's 4, so 2 to the negative 2 will give me 1/4. But I also still have that exponent here, the negative x plus 4, on the left-hand side of my inequality. Everybody with me so far? So then, Jenna, as you said, we're going to distribute that negative 2. The reason that we do that, anytime we have an exponent raised to an exponent, what operation takes place between those values? Well, not just multiplication, right? So I have the same base. I'm going to set the exponents equal to each other. And then to simplify, as you said, we're going to do distribution on the left-hand side. So I'll distribute that negative 2. Negative 2 times negative x is going to give me what? 2x. Negative 2 times 8 is going to give me, or excuse me, negative 2 times 4 is going to give me negative 8. So I just gave it away. And then that's less than negative x plus 16. Nothing changes on my right-hand side. Okay. Try to get my variables to one side, my constant terms to the other. So I'm just going to do 2 steps at once. I'm going to add 8 to this side, and then add x to the left-hand side. I get 3x is less than 24. So then my final answer is that all of my values for x have to be less than 8 in order for this inequality to be satisfied. All right. Any questions about that example? All right. Let's go to example 3. What should my base be on either side here? 2. Good. Right. A lot of times we might have to change one side, might have to change both in this example. And sometimes like they'll give it to us like yesterday in the homework assignment, for example. I forget if it was this class or another class, but it was the 25 and the 625. So we changed it to 5, but sometimes you're able to just leave it as is. In this case, there is no number I can raise 4 to have the same base as 32 and things like that. So I got to change it to 2. All right. So on the left-hand side, what should my exponent be? 2 raised to what power gives me 4? 2. What else do I have on the left-hand side, though, as an exponent? 2x plus 1. Good. On the right-hand side, if I want that base of 2, I'm going to raise that to what exponent? So 2 raised to what exponent gives me 32? 5. And then I also have the x minus 3 over there. My bases are the same, so what can I do with my exponents? Set them equal to each other. So I have 2 times 2x plus 1 is less than or equal to 5 times x minus 3. Everybody with me up until this point? Do we have any questions? So I'm going to distribute on both sides. 2 times 2x will give me 4x. 2 times 1 gives me 2. 5 times x gives me 5x. 5 times negative 3 gives me 15. Okay. What do I do from here? So I have 4x plus 2 is less than or equal to 5x minus 15. What should I do on both sides? Good. Subtract 4x, add 15. So I get 17 is less than or equal to x, or x is greater than or equal to 17. So any value greater than or equal to now, 17 is going to help me satisfy that inequality. So when I plug values in, if I wanted to check, and a lot of times when you're dealing with these inequalities, right, you see that we're going to be dealing with some higher powered exponents. So you might want to use a calculator or some other kind of resource to help you check your answer, right? If I'm dealing with a number that's, 32 raised to the 14th power, I'm not going to understand what that is off the top of my head. So to compare things, make sure that you have that resource available. Okay. Any questions about 3? All right. 4 is a little bit trickier, but you will see a question like this on your homework tonight. So in number 4, what do you think my base should be on either side? 6. Okay. I'm dealing with 2 fractions, so it's going to be 6 raised to what kind of number? Positive or negative number? Negative, right? So those two things should be our first questions for ourselves. What should my base be on either side? And then if I'm dealing with fractions, I need to understand that it's probably going to be a negative number. That's going to be my exponent, right? So on the left-hand side, let's just do this one step at a time. I have 1 over 36. So what number should I raise 6 to in order to get 1 over 36? -2, good. So I just changed that base. I'm going to put that in parentheses. What else is left over on this side? What's my exponent? 3x minus 4, good. That's going to be less than or equal to good. So I have 1 over 1,296. All right. That is 6 to the 4th power, or 6 to the -4th power in this case, since it's a fraction. So once you understand what your bases should be, again, if you have a calculator or some other resource, it's going to be easy for you to just kind of keep multiplying till you get to that value. But just keep in mind that it has to be a negative number since you're dealing with that fraction. Is everybody familiar with that idea? Does that make sense? Okay. Now that I have the same bases, again, my process gets pretty easy. So I have -2 times 3x minus 4 is less than or equal to -4. And it's okay to just have a constant term on either side of your inequality or either side of your equation. All right. So don't think like you always need to have variables on both sides. Distribute on the left. I have -6x plus 8. Careful with your integer rules. Subtract 8 from both sides. I get -6x is less than or equal to -12. Divide by -6. I get x is what? It's not less than or equal to. Right? I'm starting to move quickly through this, but let's not forget, if I divide by a negative, what happens to my inequality symbol? Flips, right? So it's going to be x is greater than or equal to 2. Be really careful about that idea, right? Like I said, that's pretty much the only thing that's different about equations and inequalities is I can't just go through and solve normally. I have to worry about if I divide by a negative or not. So x is greater than or equal to 2. So now when I plug in values, if I were to go through and check, and what I was suggesting, like I said, if you have time on homework or test or quiz, now I have to plug in values that are greater than or equal to 2 rather than less than or equal to, right? And that would be a good sign of, did I make a mistake somewhere? If you plug in like 0 because you thought it was less than or equal to, obviously the inequality in the beginning is not going to be satisfied. So make sure that you flip your sign there. All right. Any questions about anything that we've covered so far? Okay. So what I want us to do now is take some time to do this review check. All right. So everybody should have their laptop or Chromebook out, or if you are doing it, if you don't have those resources and you need to use your phone, that's okay. But you're going to go through this. It's 3 questions. I'm giving you about 15 minutes to complete it. And then very quickly towards the end of class, what we'll do is just kind of go over each question, and then I'll explain what the homework assignment is for the day. And then we'll be done for the class period. I'll kind of just outline what tomorrow and the rest of the week's going to look like. All right. So this is going to be just independent practice. I want you to try and do these problems on your own. You have about 15 minutes and a time limit there to get them done. So please make sure that you are, aware of that. And then after that time, like I said, we'll go over each of these. So this is what you're doing for, the next 10 to 15 minutes or so. All right. So go ahead and get to that. If you have any questions along the way, please make sure that you ask, and then we will reconvene in a little bit. All right. Freeze the screen here. You have a question? All right, 1 second. Sorry. So if your answer is a fraction, just leave it as a fraction. All right. Also have yeah. So we change your place, I just leave it. So I know all I do is replace it. That's yeah. For the inequality problem, make sure you're typing in the inequality expression. So you're not including any spaces, but it would be like, for example, x is less than 3 or x is less than 4, whatever it is. You're going to type that in. You can use the greater than and less than on your computer there. Okay. After you're done, make sure that you submit everything. So don't just fill out the answers and then close out. Make sure that you actually submit it. Bless you. In about 2 minutes, we'll go over these. So if you're still working, which doesn't seem like it's a lot of people, please make sure that you finish up in the next couple minutes here. Okay. So we're going to go over these. There were 3 different questions that you saw, depending on the order. I think they were kind of randomly ordered. Let's take a look at these first 2. So one of the first equation type problems, you had 2 to the 3x plus 1 equals 1/4 to the x minus 3. All right. So very similar to what we saw with one of the inequality questions today. I'm going to keep the 2 the same. So I have 2 to the 3x plus 1. The 1/4 is 2 to the -2, and then I still have the x minus 3. Now that I have same bases, I can set them equal to each other. So 3x plus 1 equals -2 times x minus 3. When I distribute, I have -2x plus 6. I'll add the 2x and subtract the 1 from both sides. You get 5x equals 5. Should have got x equals 1 for that value, all right? To check your answer, if you were to plug that back in, you have 2 to the 4th power, which is 16. Then you have 1/4 to the -2 power. That's the same as 4 squared, which is also 16. So you should have got x equals 1, all right? In the inequality problem, you had 3 to the -x plus 1 is less than 27 cubed, right? So I'm going to rewrite the right-hand side. So it's 3 cubed to the 3rd power. So I have -x plus 1 is less than 9. Subtract 1 from both sides, divide by a -1. When I divide by a negative, my sign flips. So I should have got x is greater than -8 for that. All right. And then in the last example, 5 to the 2x is equal to 25 to the 2x minus 4. Well, I'm going to change the right-hand side, so it's 5 squared. When I set my exponents equal, 2x is equal to 2 times 2x minus 4. So then when I distribute, I get 4x minus 8, and I should have got x equals 4 for that. Okay. Are there any questions about any of these examples? Saw some people missed about 1 or 2 out of the 3. So please make sure that you are asking questions if you made a mistake somewhere. All right. For the most part, everybody did pretty well, but there were some interesting mistakes that I saw. Any questions about any of these? Okay. All that I have left to kind of explain is the homework for tonight. So you're doing 3 problems again, very similar to what we had on Tuesday. On page 464, doing numbers 25 through 29 odd. So you see here, you have some where you don't have fractions at all. You just have to change one side. Changing one side with a fraction, so remember your negative exponents, and then changing both sides with negative exponents as well. These are inequalities. Be careful of your flipping them when you have a negative that you're dividing by. Pretty much the only rule that, like I said, we need to kind of keep in mind. When you come into class tomorrow, we'll go over that problem, and then we will begin our, I guess, supplemental study, you could call it, of compound interest. So actually applying this to some real world situations and getting an idea of where you might see this in your day-to-day lives moving forward. All right. Any questions for me about the assignment for tonight or the expectation for tomorrow? Cool. With that being said, those of you that are at home can go ahead and sign off. Have a great rest of your day. I'll see you all tomorrow. Those of you that are in here, just wait for the bell to ring, which is in about a minute or so. All right.